Hello everyone, welcome to your daily physics problem, day number 35. So today we need to estimate the distance between Earth and Moon by knowing the fact that the radius Earth is 6,400 kilometers. And that's the only thing we know, and the only thing we need to solve is one thing. It's the distance between Earth and Moon. So I want you to pause the video, try on your own, to try, come back to the video, to show you how I did it. And give you a hint, have to be something with gravity. So welcome back guys. So first, let's lay out a little diagram. We know we have Earth, have a mass of ME, radius RE, and then we have a moon, a little smaller, and it's orbiting around the Earth, have a mass of M, and have a velocity of V, traveling through a curved trajectory. So now, based on this relationship, we can lay out our gravitational Newton's gravity relationship, that G times ME times MM over the distance between them, that's defined as REM. REM is distance between Earth and Moon. Then we square is equal to M times omega squared times R, and that will be the centripetal force of the Moon, the equivalent of them. And the second identity we need to know, take it for granted, is that if we put any mass on Earth, we will feel our acceleration that equal to mg. That can also be expressed by G times ME times M divided by RE squared equal to mg. So from these two system equation, we can try to solve it. On the last, we can cancel out the M, and we solve for G times ME. That will be equal to G times RE squared. Then G times R, we plug it back into the first equation. We have G times RE squared MM, MM cancelled out from left right hand side. So let's divide by both sides by R3EM. R3EM to the cube is equal to omega squared. So REM will be equal to R times RE squared divided by RM squared, and all of them to the square root of 3. Then what is the omega of M? We know the period that Moon need to travel around the Earth is 30 days. So omega will be equal to 2 pi divided by t. So we can simplify it to pi divided by 15 days. Then we need to transfer the unit of days into seconds. So we need to multiply by 24 hours, and at each hour have 3600 seconds. Then by knowing, we know the period, the frequency, angular frequency, we know the distance, the radius of the Earth is 6,400 kilometer. We can know, we can just plug it back in. G is equal to 10. We are ignoring the unit here, but too many to track. And we know the unit is right. And then we have 6.4 times 10 to the 6 meters. That will be a unit change from 6,400 kilometer square. Then times the seconds it takes to orbit around the Earth. Now that's the angular frequency. And then divide by pi squared. And all of them to the square root. We find the answer is 4.1 times 10 to the 8 meters. And that's the distance between Earth and Moon.